Good morning, everybody. If you can believe it, it is already week 3 of online learning. And so today we're going to start some material related to actual calculus for this class. And so to get a running start at the notion of a derivative of a function of several variables, let's talk about how this used to work in single variable calculus. The derivative of a function measures a rate of change, a speed. It tells us how fast the function is changing as we change the input, and it tells us that at a particular instant in time. So just as in the real world, your speed can change in a continuous way, and the derivative also changes to measure how that's changing. And in terms of the graph of a function, all my graphs of functions looks like this. The derivative tells us the slope of a tangent line, the closest possible line to a graph at this point. If we calculate the slope of that closest possible line, it tells us the derivative, and then this closest line here is given by the graph of this function that we see on the right-hand side. It has a constant factor that tells us how high we are, and it has this here, and this is a kind of point slope form for a line. All right. Now, the actual calculation of derivatives is done using this limit definition. The derivative f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. And we have a ton of different notations for the derivative. So we wrote df dx or d dx of f, or if we don't usually use this because we're not physicists, we also might see the notations df or dxf as operator type notations. There's lots of different names for us, but they all are names for the derivative. Some of them are going to be a little bit easier to use when we talk about functions of several variables. And if we instead are in the situation where we have one output that's a specific function of the input, like y is equal to f of x, we sometimes also use the notation dy dx, like so. Now, for functions of several variables, we have more things that we're going to have to keep in mind when we do these types of manipulations. We have a bunch of different outputs and a bunch of different inputs. And so when we change the input, like we do with a function of a single variable, we could change the input in a bunch of different ways. And so we'd like to know, how does that affect our notion of a derivative? What is changing this input in this way due to the output? What is changing this input in this way due to the output? And what happens if we change a bunch of them at the same time? And similarly, what does it mean to be differentiable or not differentiable? That's going to be a slightly more complicated notion than we had for just functions of a single variable. And it has to do with the fact that limits in 2D or 3D or so on are more complicated than they used to be.